Now that we got our diagram showing the relationship between the activities in our project, remember that you always need to do the diagram first, whether it's CPM or PERT. The only difference between CPM and PERT is in regards to the estimate of time for each of the activities. With CPM, we just give you a single estimate for each activity. We would traditionally use the most likely estimate, or what we think the activity will take. And then you would simply do your forward and backwards pass. I'm going to show you how to do the forward and backwards pass using a more sophisticated, or the PERT method, because you'll see that we have actually three estimates of time. We have the optimistic, the most likely, and the pessimistic. And so we have a higher degree of sophistication in regards to our calculations. But like I said, the only variation between CPM and PERT is that CPM will give you a single estimate, usually the most likely, whereas PERT will give you three estimates for each activity. But of course, to do the forward and backward pass, you have to calculate the expected time, or a calculated time. We have to get to a single estimate of time. The way you do that in PERT is that you take and use this formula. The formula is that you do a weighted average. And so we're going to include the optimistic plus 4 times the most likely. We give the heaviest weight. So the optimistic is only given a weight of 1, while the most likely is given a weight of 4, plus the pessimistic estimate. And then we divide by the sum of the weights. So optimistic has a weight of 1, most likely has a weight of 4 as we're showing there, and then pessimistic has a weight of 1. And so the sum of the weights is 6. And that would then give us our expected time. You'll see for the most part, it's not going to move away from the most likely unless the optimistic and the pessimistic are way far apart from the most likely. We can then copy this formula down. We can double check that it did it correctly, and that we can take a look at this and click on one of these, and you'll see that once again it took the optimistic plus 4 times the most likely plus the pessimistic and divided by the sum of the weights, 6. So we now have the expected time, and these are the things that we would use. You'll see that for the most part they stayed with the most likely, 2, 3, 2, 4, 4. Here's where it changed a little bit. You can see that our optimistic estimate is quite, or our pessimistic is a 9, and so therefore we bumped this up to reflect 3 weeks. And also here on activity G, instead of staying at the 4 weeks, we're going to expect or estimate that to take 5 weeks given the range of time we have between the optimistic and pessimistic. So once again, we can take these 3 time estimates and combine them to create an expected time by using the formula a weighted average, where we take the optimistic plus 4 times the most likely plus the pessimistic and divide by 6, the sum of the weights. And then that would be the single time we use for our forward and backwards pass. I'm going to pause it there and come back and talk about how you calculate variance, and then also set it up for doing our forward and backwards pass. You can see that I labeled the expected time here. This is the one that we calculated. While we're doing this calculation, we might as well calculate the variance. Not that we will use the variance for each of the activities, because we're only concerned with the variance that is on the critical path. But we might as well do it now for all the activities because it's easy enough. Later on, when we're done with our forward and backwards pass, we'll know which variances we need to pay close attention to. The way you calculate the variance is you look at the overall range. And what you take is you take the pessimistic, because that's going to be the larger of the numbers, and you subtract the optimistic, and that gives you then the range. You then divide by the sum of the weights, 6, and then you square it. And the way you do squares in Excel is you use this little, what's called the caret sign, or sometimes referred to as a hat. It is the symbol above the 6 on your keyboard, and then a 2, and that would square it. If we wanted to cube something, we'd use the caret sign and a 3 to cube it. So we're going to calculate that. Now that I've done it, I can copy that formula down. Once again, let me just do it for you. So I'm going to take then, and make sure you use plenty of parentheses so you do order of operation correctly. We're going to take the pessimistic, we're going to subtract then the optimistic. That will give us a range. We're going to divide that by 6, and then you'll see that I have an outer set of parentheses to make sure that we do the squaring last, and we use that caret sign and 2, and that will give us that. So I can copy this down, and then I have the variance for each one of those. You can see that activity F and G has the largest variance, while activities A, B, C, and H have the lowest variance in the model, meaning they don't vary a whole lot. And that should make sense because our range here is between 1 and 3 or 2 and 4 as compared to these where it varies from 1 week to 9 weeks or 3 weeks to 11 weeks. So those are our largest variances. We're now ready to do our forward and backwards pass, and I'm going to save that and do that as a separate video. So hopefully you understand that if we were to do CPM, we could just take, if we had just a single time, we could go ahead and do the forward and backwards pass. But with PERT, you have 3 estimates, and you have to convert those into expected time so that we do have a single time for each activity. And then we go ahead and calculate the variance because we'll need it later because of some of the values that PERT allows us. But I will show you then how to do the forward and backwards pass in the next video with this single time for each activity.